Sometimes it's surprisingly useful to be able to just look at two different expressions involving trig functions and say whether or not they're equal. That's what this video will be about, and I'm going to show you a really nice real-world example, and then we'll work through a more simple example that's more at the level of first-year trigonometry students. So first, let's say that you're leading a team of engineers and your team has been tasked with taking a solar panel into space. And what that solar panel will do is absorb energy from the sun and then convert that energy and be able to send it to anywhere that it's needed on the Earth. This technology is new, so your team will set up an experiment that measures the efficiency at which this energy is being converted by your system. And one quantity that will come up that will be important is the angle at which the sun's rays are coming in and hitting your panel. So you'll have a sensor like this one that measures two angles. So it'll take in the sun's rays, and then what it will tell you is these two angles labeled alpha and beta in this picture. And what you want your team to then do is take those two quantities, alpha and beta, and convert them into the angle from the sun's rays from the sun's rays up to the vertical line that's coming out perpendicular from your solar panel. You want to know how much that angle is affecting the efficiency of your system. So you get your team on it, and before long, an engineer comes up to you and says, I've got this angle calculated. This is the angle. And you've got this expression involving the inverse cosine function and a fraction and a square root. Then a little bit later, another engineer comes up to you and says, I got the angle. This is the angle. And they give you this expression involving inverse tangent and no fraction. So the question to you is, are these two angles equal? Are both of these giving the same thing? This example is from a real mission launched by the U.S. Naval Research Lab in 2020. And I will put up some related links in the description of this video, just in case this piques your interest in a strong way. But this issue of being able to take two expressions involving trig functions and say whether or not they're equal is pretty common in powerful applications of trigonometry. By the way, these two expressions do turn out to be equal, but I won't take the time to prove that here. Instead, let's look at this more simple example. Let's say we're told to verify that this equation is true. And immediately I should say that what we mean by that is you should assume that we're talking about the natural domain for both of these. So, for example, cosine can't be 0 and sine can't be 0. Those things should just be assumed here. And then what you should do is usually you want to start with the more complicated side of the equation. So in this example, I'll start with the right-hand side of the equation. And then you want to show that that right-hand side is actually equal to the left-hand side. So that's what I will try to do here. Let's see how it goes. Now, before we manipulate this right-hand side, we should take a look at the left-hand side just to kind of see where we want to go eventually. So when I look at the left-hand side, I see this secant squared and the tangent squared, and that makes me think of the Pythagorean identities. So remember, cosine squared of an angle plus sine squared of the same angle is always 1. And if you divide all of those terms by cosine squared, you get 1 plus tangent squared equals secant squared. And then if you subtract the tangent squared from both sides, 1 is secant squared minus tangent squared. That's what we have on the left-hand side of the equation. So I expect that the right-hand side of the equation will also be equal to 1. So that's where I'm going to try to go with this. The first thing that I'll do is just take the expression and rewrite everything in terms of sine and cosine, just to see if I can quickly make any simplifications. So when I do this, I see that I've got fractions in the denominator. I know that dividing by a fraction is the same as multiplying by its reciprocal, so that's what I'll do. And then you can see I've just got cosine squared alpha plus sine squared alpha. We know that's equal to 1. That's what we were expecting. And then we can say 1 is equal to secant squared alpha plus tangent squared alpha. So we showed that this equation that we were given is indeed true on the natural domain of these functions.